The last three things are the things we've already done, okay? The first three are what's going to be new in terms of getting a common denominator, okay? All right. So question one, I'm going to form a common denominator. When you form a common denominator, you have to make sure that each of the separate denominators are factors of the common denominator. So, in other words, in this particular problem, this first one, I can't go smaller than 12 because 12 wouldn't divide into 6, okay? Or 12 would not divide into 2, or 12 would not divide into 3. So when I form my common denominator, you've worked enough with number denominators that you know that I can't go smaller, okay? So when I form my common denominator, I need a 12. So 6 and 12 both divide into 12. If you accidentally did 24, it would still work. You just have extra step to do, okay? Then let's look at the other factors. I have an x, and I have an x to the third. So if my denominators are going to be able to divide into my LCD, I'm going to pick the highest power here, so x to the third. And then this particular denominator has a factor of y. The other one does not, but that means I still need it if one of them has it. Okay, so this is part of this, and this is part of this. If this is smaller than either of these two things, it's not going to work. Okay? So, I'm kind of going to put two steps into one, so we don't have as much writing to do. Now, what I do is I look at the denominators and compare them to the common denominator. So what does 6xy need to be multiplied by to be 12x to the third y? So kind of like this. Kind of like that. This is what I want you to be thinking of. Let's say I'm adding 1/2 and 1/3. And my common denominator is 6. And I would be going, what do I multiply 2 by to make it 6, to make it my LCD? I multiply it by 3. And what do I multiply that by? I multiply by 2. I'm doing kind of that same process you do with regular numbers, except that I have more there. Okay, I have letters now. So, compare. What does 6xy need to be multiplied by to make it 12x to the third y? Evie? 2x squared. 2x squared. So I put that up here. And then what does my 12x to the third need to be multiplied by to make it 12x to the third y? What's that?
Y.
Well, because I want to know. I don't get many jokes in, okay?
I thought it was funny.
Thank you. Thank you. All right, so I multiply what I have then in my numerators. 5 times 2x squared is 10x squared. Let's go back to blue. Minus 7y. Once I do that, it works like my common denominator questions now. Do any adding that you can. I can't add any of those things in my numerator. Factor if I can. I cannot factor that in any way or shape or form. And then reduce if I can, and I can't do that either. So that one's done already. That's all I can do. I'm going to star this next question because it's so commonly missed. And it looks like a simple question. And it kind of is a simple question, but people miss it because you have to understand that when you have a group, that a group has nothing to do with anything else. So this x, that's part of this group, has nothing to do with this. This would be like having, for my denominators, a 2 and a 3, like prime numbers. They have no shared factors, okay? So x plus 6 as a group must be as a group, has nothing to do with that. So when I form my common denominator, I think the best way is to kind of work across. I need an x plus 6 as part of my common denominator. So I put it over there. Then I go across to the other one. I need a plain x. So I put it over there in my least common denominator. So kind of form it from the denominators that you have. And I'm trying to hit a real variety of questions, or problems here that we're doing that are different from each other. And then I do what I did on the last question. I start comparing. So what does x plus 6, this denominator, need to be multiplied by to look like this denominator, which is x times x plus 6? So it's missing the plain x. And then I compared this denominator. This denominator needs to look like my LCD. It needs to say x times x plus 6. It has the x. It's missing the x plus 6. And then I'm going to multiply through. 7 times x is 7x. Watch your minus here. Distribute that with your 3. Minus 3 times x, minus 3x, and minus 3 times positive 6, minus 18. Okay, so that's my unlike denominator part. Now I follow my 3 steps. Can I add or subtract anything? Yes. I can make my x's combined to 4x minus 18 over x times x plus 6. 3 things. Think, can I factor anything? Yes. In my numerator, I have a common factor of a 2. And then third, can I cancel anything? No. So that's my answer. And just so you know, we're going to work on this a couple days. Anything you would like to ask from that? And again, I star that as a missed question because some people simply want to make the common denominator just x plus 6. Yes, sir?
So if you wanted to like write out 3 times x plus 6 on top of the denominator, could you cancel the x plus 6's?
You cannot, because this is a subtraction. So I can't do that. Or an addition or subtraction, you couldn't do it. Okay, in my next question, to form my common denominator, as I said, if any denominator is factorable, you need to do that first, and these are factorable. I can take out a common factor of 3 on the first one, and it's not 3, that's 5 then. I was saying 3, and I can take out a common factor of 5 on the second one. So if a denominator is factorable, do that before you get your common denominator. Okay, so what do I have? I have 3 times x plus 5, and I have 5 times x plus 5. So both denominators have a constant or coefficient term. So think of putting those together like you would do as if you were just adding something over 3 plus something over 5. The common factor for that would be 15. So I take my coefficients and I make a common number for those. So 15. Then each of them have an x plus 5. So I need to make sure I have an x plus 5 in my common denominator. I only need to write it once. I do not need it twice, because this is a factor of that or divides into it. This is a factor or divides into that. So look carefully now. What am I going to multiply 3 quantity x plus 5 by to be this 15 quantity x plus 5? Somebody? Anybody? I want to make this look like that. Yes?
Just multiply by the 5.
Just multiply it by the 5. That would make it 15 x plus 5. And what about the second one? What am I going to multiply it by now that you've seen that one? Evie? By 3. So I'm comparing. I'm deciding what do I multiply this by to make it look like the LCD, the least common denominator. All right, let's multiply through. So I have 5 that I'm going to distribute, 5x minus 5, minus, watch my minus 3 times x, minus 3x, minus 3 times positive 3, minus 9. That's the hard part, getting that. Now think 3 steps. Every time, once you do that, think 3 steps. Can I add and subtract anything? Why, yes, I can. I can make it 2x minus 14. Can I factor anything? Why, yes, I can take out a 2 in my numerator. And then could I factor or reduce anything? And the answer to that's going to be no. Sometimes you're going to see on these, like this 2 and this 15, those numbers would be something you could reduce. This one doesn't, obviously, but sometimes that might happen on a question like that. So that's my final answer. Again, once you get it written, this is the hard part. Once you get this, think 3 steps. Add, subtract, factor, reduce. I got 2 more there? Okay. Okay, next question. I have a denominator that's factorable, so do that first. And that factors into x minus 7, x plus 6. So I form my LCD. Start over here. I need an x minus 7. So I go and I write that over there. I need an x plus 6. I go to my second fraction. I need an x minus 7, which I already have, so I don't have to write it again. So I have an x minus 7 already, so I don't have to write it again. All right, so first denominator. This denominator looks exactly like your LCD, so I'm not going to multiply it by anything. My second denominator is missing the x plus 6, so that's what I'm going to multiply it by. I'm doing that in pink, aren't I? X plus 6. Okay, so I'm going to multiply through. My 3x plus 5 is just going to come over. And when you get to that second fraction, you should be, I don't know why I put an equals, you should be thinking, what? FOIL. You should be thinking FOIL, because you're taking x minus 9 times x plus 6. So first times first. And this is great that it's a plus, because then we don't have to worry about any sign changes. So first times first, x squared. Outer times outer, plus 6x. Inner times inner, minus 9x. And last times last, minus 54. Think 3 steps. Step 1, add. So x squared, 6, 7, 8, 9, minus 9. X's all cancel. And then minus 49. 5 minus 54. Oh, I like this question. So add and subtract, factor if you can, and I can. I have a difference of squares. In my numerator. And then third thing you're thinking is, can I factor or reduce? And the answer to that is yes. I have additive, or not additive inverses, I have the same exact term. X minus 7 over x minus 7. A little bit longer one there.